you cast your mind back to core 1, probably won't remember the exact objective, but it was 7.7. It talked about rates of change. So, for instance, if we have y equals 2x squared, then we can work out the rate of change of y with respect to x, which is a wordy way of saying find dy by dx, i.e. differentiate. This comes up a lot more in core 2, so just a very quick recap. This is a problem taken from the mixed, well, not the mixed exercise, exercise 9c. This is question 4. I've assumed that we've done the first part. It says show that a equals 40r minus all this stuff here. So this is exercise 9c. The second part, however, says find the maximum value of a. Now, we can use differentiation to find something out here, and that is we can find out the rate of change of a with respect to r, dA by dr. We just need to differentiate in the same way, so that anything that's not r we treat as a constant, and we know that pi is a constant, so we just treat it like a normal number and don't worry about it, and then we differentiate just as if the a was a y and the r was an x. So this is going to find us the rate of change of a with r, and then in the same way that we've been doing for these other problems, we can use this to find a maximum value or a minimum value by setting dA by dr equal to 0 to find turning on stationary points, rather than setting dy by dx equal to 0. So what is dA by dr? Well, the first bit's quite easy. If we were to differentiate 3x, we'd get 3. Well, if we differentiate 40r, we get 40. The second bit's fairly straightforward as well. Multiply by the power, reduce the power by 1. Third bit, don't get confused. The pi over 2 is just a constant. It's just a number. All we're differentiating really is the r squared part, which I'll colour in purple there. So again, we just multiply by that power and reduce the power by 1. So minus pi, let's just do it in steps, 2r over 2. And those really switched on will have noticed, let's do another row, first two bits are the same, that actually the 2's cancel, and we're left with minus pi r. When we then put that to 0 under here, that implies that 40 minus 4r minus pi r equals 0, and using that we can put all the r terms on the other side, 4r plus pi r. Do a bit of factorising, and we should find therefore that r equals 40 over 4 plus pi. So that is the value of r that makes a stationary point, and it tells us to find a maximum point, so we actually know that that is the coordinate, if you like, of a maximum point. Key message is the rate of change of a with r and finding the maximum minimum values of a is the same problem but with different letters and in a different context. You still differentiate and you still put the derivative dA by dr equal to 0.